we're going to go over function notation, and function notation is just a way that we write our functions. It's going to be this nice and easy mathematical way to talk about things and kind of save space and words so that when we're talking about these things, we don't have to go through the whole process of writing a paragraph. It also lets us talk about graphs and specific points on a function without too much work. Our goals then are to be able to understand what function notation is and be able to look at it and be able to spit out what it's asking. We also want to be able to use this function notation to our advantage to evaluate the function at certain points and along a graph. So we're going to talk about it, and we write these functions, as I said, in a special way. And the way that we're going to write that is f of x. So we have this f parentheses x, and that's going to be equal to whatever our function is. For example, if I had f of x, so if I had like an equation y is equal to x squared, and I wanted to write this in the function notation, I would write it as f of x is equal to x squared. It's saying that our function has a relationship x squared, so we put in, we square it, and that's going to be our output. Now note here that this does not mean multiplication. So we are not multiplying anything here. It doesn't mean that we're taking this stuff and multiplying it by x. That is not what is going on here. What's actually going on is it's just telling us what our input is. And when we write this, what it does is it tells us what the function's name is, its input, and its output. And we'll talk about those in just a second. But we can use these to explain and simplify our process, because instead of writing down f of x is equal to, we just write it as f parentheses x and move on. It also allows us to evaluate things, and we'll talk about how we evaluate our functions at certain points. So, understanding notation, we have our green stuff, our blue stuff, and our pink stuff. So our green stuff, which is going to be this f in these parentheses, that's our function name. Everything that we have can have a name. We can call it f of x, we could call it Fred, we could call it George, we could call it g of x or h of x. Some other examples that we're going to see later are going to be position time. So we'll have p of t or p of s for like position times seconds. And we'll see that later. Our input is the stuff inside this parentheses. So that's what the function, like that's what we're putting in to our function. And our output or relationship is going to be what's on the other side. So f of x is actually saying this function is a function of x. So when we plug in x into this function, we're going to get something out, just like in our machines that we have, like our washing machine. Our washing machine is a function of dirty clothes. We put in dirty clothes and we're going to get out clean clothes. And so we're calling this magical function a washing machine. And we know that when we put in dirty clothes, we get out clean clothes. It's the same thing here. We have a name of this function. In this case, it's f of x. So our function, we put in f, and it is a function of x, and we get out something, and that something is that relationship. It's our x squared. Now, for each of these functions, here's a quick check. What I want you to do is, for each function, identify the name, the input, and the output. So you'll just go through, and I'll do one of these for you. You'll say, so what's the input? Well, our input is our x. Our name is f. And our output is going to be all of this junk. That's our relationship. And I want you to go through and figure out what each of these things is for these particular functions.